Hello and a warm welcome. My name is Steffen Lang. I'm from AKRO. So looking at the audience here today, I'm really happy because it reflects also what we see not only on our booth here at the K show, but also in our daily project work. The interest in polycatone is definitely growing. And I had the pleasure to join the seminar Houston was giving on the K class at the China class in beginning of this year. And so thank you for having me again. I take it as a compliment that I'm allowed to speak again. So yeah, starting with a very brief introduction on AKRO. So AKRO is a compounding company. We are specialized in engineering thermoplastics, semi-crystalline thermoplastics, and our headquarters is only about an hour drive south from here, from Düsseldorf. But we are not only a German company, we are a global company, and you see it here on our map. We have production facilities in Europe. We have 2 production plants in China. We have 1 in Brazil, and the next plant we will open will be in US, in Texas. So, well, we are a compounder. There are many compounders. What makes AKRO different from most other compounders? First, well, we are part of the K.D. Feddersen Group, and the K.D. Feddersen Group is owned by the K.D. Feddersen Foundation. So, and the only job the foundation has to do is to run a retirement home for elderly people. So that is pretty much what we do. We make sure that around 250 elderly people have a nice life. And that reflects on our whole business DNA, how we do business as partners. So we are interested in long-term relationships. We are interested in a fair cooperation with our partners and also with our employees. So secondly, we have a very, very strong focus on sustainability. So, well, there are also many companies doing this, and that is great. And we are not only doing it because we see it as a moral obligation, but we're doing it because we strongly believe that this will just bring us a more successful future, also, business-wise. So I cannot imagine that we will have a time when we sit together and say, can you remember when everybody was worried about climate? And so I'm happy these days are gone. So I think that will stay with us for a long, long time. So we focus on this. And the third and last topic I'd like to mention is the ICX technology. ICX technology is our in-house technology to compound, and this is the same in every location, every production site we have. So we are running on the same lines in China, in Brazil. We will run on the same lines in the US. And the special thing about it is that these extrusion lines are produced by our sister company, Fedden. So they are also tailor-made for our needs, for our materials needs, and for our customers' needs. Okay, so that's for AKRO. And now I'm happy to share some interesting new serial applications. But when I was asked by Houston to if I can give the presentation again, I said, okay, I just take the old presentation, which I showed during China Plus. But then I realized that in the last 6 months, maybe a bit more, we had so many new great applications that I'd like to share with you. So yeah, I had to do more or less a completely new presentation. So one very important field, and it was already mentioned before, of course, the battery electric vehicles. It's like a perfect match, polycetone and battery electric vehicle applications. And there are good and many reasons for that. Looking into thermal management of a battery electric vehicle is completely different from a combustion engine. In a combustion engine, you need more or less to cool the engine while the car is running, temperature control the engine. In a battery electric vehicle, you also need to take care of the temperature of the battery while it is standing outside in winter times. So it must not go below a certain temperature. You must control the temperature in your fast charging unit. you must control so many different converters, inverters, and on top, then you have also the heating, ventilation, air conditioning. So you see immediately that there are many jobs to be done, and therefore you have very complex modules. And they need to be very high sophisticated because you do not want to cool or control all these different components at the same time, because you only want to control what is really needed to not waste energy. So, and therefore you have these manifolds, and these manifolds are quite complex parts. So many of them are made in semi-shell technology, where you have two layers or one base plate, and you weld different channel components on top. And then you can use different welding technologies. You can do laser welding, you can do vibration welding, ultrasonic welding, whatever. Depends on your part design. But what you will get in the end are weld lines somewhere. And weld line in combination with temperature, in combination with the cooling agent, and over quite a long lifetime. So you have in these parts of really high requirements regarding precision, reliability, and of course the tightness of these weld lines. So I already mentioned the system in use time in a battery electric vehicle is much different from combustion. So in combustion engines, we test for 3,000 hours. Now, if you look into battery electric vehicles, 15,000 would be nice. They go even to 30,000, which is already 10 times the in-use time compared to a combustion engine. And we have already customers asking for even more, for 45,000 hours, 15 times the time of a combustion engine. So that makes it necessary that you use really the right material, and polypropylene, some say polycrepylene, creeps a lot, and there are reduced polypropylene types, but after such a long time there is creep. That's just the nature of the polymer. Yeah, it's hot-good oil. So therefore, we see polyketone as the most competitive solution, and I can give you a recommendation, use AKRO PK for these kind of applications. So we heard already a lot about hydrolytic resistance, about the test results. I'm glad that the numbers we saw so far match with what I prepared, but we do not need to go through this chart again. What is also interesting is the sustainability aspect of polyketone. So just comparing two fossil-based materials, having a nylon 6,6 with 30% glass fiber, or having a polyketone with 30% glass fiber, you see, without using any kind of recyclate or doing anything really, it's now fancy, sustainable, you already get close to 30% reduction in carbon footprint. That's quite something. So another topic that is often discussed and that reflects kind of a fear of our customers is the cross-linking behavior of polyketone when processed in an injection molding process. So what you see on this chart is maybe a bit confusing in the beginning. You see two lines. The blue line is from our AKRO PK grade. Orange line, just let's say a conventional polyketone. And you see the injection pressure while during the injection molding process. And we use the injection pressure as an indication for the change of the viscosity, and this reflects the cross-linking behavior in the mold. And we saw, okay, in the beginning, you were quite on a similar level, and then we started to increase the cooling time just to make the material suffer a little bit more under temperature and to activate like the cross-linking process. And we could see by increasing the resistance time in the injection molding barrel, this is standard polyketone, it really goes up a bit, and you can even do it further. So we had a stable condition here, and then we increased it by another 5 minutes. and it went even higher. So it was quite a logic behind. And so we were able to develop our own stabilization package for polyketone to, as you see, well, we could say it decreases a bit, but compared to an unstabilized polyketone for the processing, we were really able to reduce this behavior. And that is really well appreciated by customers. We always see it when we attend trials. We say, okay, now stop the machine for 10 minutes. Oh, we are not going to do it. And they're really surprised that it works now. So, and this is not only working for standard grades, but it's also working, for example, for the laser transparent grades we also use, especially in these kind of thermal control units. Okay, now coming to real parts. So this part I was not able to bring today, but you can see it on our booth in Hall 6, because it is attached to the booth. This is a very complex thermal control unit. In this case, the welding was done by, was it? No, it was a simultaneous welding. So you take both sides apart and you heat each side separately, and then you bring them together. It's simply because the structure is so complex that you cannot go through with a laser. Two-step laser. And so, well, we explained what is the task of this part, but what are the values for the customer. First, by bringing all this together in one module, we have a strongly increased energy efficiency, but also installation space efficiency. And this was tested for a lifetime of 30,000 hours. And we see here we were able to bring 26 different parts in only one part in the end. And of course, easy to acknowledge that this is a much more sustainable solution already material-wise. And also compared to different materials like nylon 6,6 or even more expensive grades like PPA or PPS. So yeah, we use here a glass fiber 30% glass fiber reinforced polyketone, and in the beginning the idea was to make it in polypropylene, but it simply did not work because of creep. And with all these many weld lines over the long time with temperature, also you get leakage when using a nylon 6,6 glass fiber reinforced, and PPA and PPS would most likely work, but it's simply more expensive. So you go for the polyketone solution. This part won the SPE award last year. So no, it was in second place, sorry, in the category new mobility. And now just last Monday, so it's a bit 1 week ago, this nice part here won the first place at the SPE award in the same category, in the category new mobility. It's also a thermal management module. It's for the Lucid Gravity. So, you know, before the first car was the Lucid Air, and I will show you later what was the solution for in the beginning. And now you already see the next step. And so here we have the same function. We replaced 11 parts by one part. And the weight saving, and that is interesting, the weight saving is not only coming from reducing parts, making it smaller, but if you look at the whole system in your car, of course, if you have less components, you have less tubes in between, and you have less cooling agent that you need in your whole system. So when looking at the weight saving of just a part, we talk about roughly 30% saving, but then on top, you could eliminate 10% of your whole cooling agent in your system, and that I don't know it by the numbers, but imagine you have like 5 liters before, and then you have only 4.5 liters left. You already save 500 grams just cooling agent. And another interesting number was the cost reduction in the end of the whole unit. And that is a number we received from Lucid as an OEM. So it's not so often that you get this kind of information. And they were able to reduce cost for the whole system by 25% compared to solution before. So, well, the reasons why EK was used are the same like for the other module. Similar application also for the PPE platform, so the performance platform electric from the VW group is from the company Voss. And here they use a laser transparent grade because it has an easier geometry, and you can go with laser transfer welding. And you see, well, here the special thing about this grade, you see by LT laser transparent, is that you have improved laser transparency. Also by we have a stabilized material and can maintain a very good laser transparency even after the injection molding process. So coming to a different kind of part, but also in a similar application. So also in cars, but not only in battery electric vehicles, also in combustion engine, you need quick connectors. Simply to connect pipes to devices or to connect the system. And here it was a very intelligent move by the company AFT. They thought this quick connector a bit different. They split it into 2 parts, separating the requirements you have. So in this area, which would be the lighter gray part, you are in contact with the cooling agent, and the darker part here outside never is in contact with the cooling agent. So you can use let's say cheaper material for this application, and you only need the high hydrolytic resistance in the area that is in contact with the cooling agent. And so you have combined it with sealing ring and with a clamp. But in the end, you can really focus on mechanics and on toughness in this area, on price. And you also have higher functionality because you can adjust the angle from head to body in 10 steps degrees. And so when normally you would have needed a new mold for every different angle, you just adjust them slightly differently. So it's also an additional benefit. And now something important comes into play, which is coming from Asia right now. It's, Chinese battery electric OEMs, they use new cooling agents. They realize if you have the cooling agents which are conductive, if you have an accident and the cooling agent is dropping on your battery and you have a higher connectivity, well, that increases the risk of a fire or short circuit. So they are going now for water glycol mixtures that have very low or no electric conductivity. So now these cooling agents are more aggressive in the first step. So we need to make sure that our materials are resistant against these special cooling agents. And luckily, the polyketone is resistant. But the second thing is, we also need to be careful as a compounder to create materials that do not release any ions into the cooling circuit. Because if we put in our formulation the wrong stuff, then over lifetime, and you saw there's a long lifetime, long use time, we can run into problems because out of a sudden this not conductive cooling agent becomes conductive. So, and also with our PK VM GF30 black, we fulfill these requirements. Therefore, yeah, that was a decision why this material is used for these quick connector applications. This connectors also won an SPE award a week ago, second place in the category powertrain. Now we learned from the presentation before how important flame retardant requirements are. And this piece is a safety cup in the MEB, so from VW Group, the modulare Elektrobaukasten. It's used in all these ID3, ID4 cars. And this was made in nylon, nylon 6. And now they, because of the propagation test and the snail penetration test and all the tests you have, they decided to move away from the polyamide to polyketone. And then, of course, well, there's a reason why it's orange, that you have this signal color, that in case of an accident, the firefighters or whoever knows where high currency is, so this should also remain a signal color and not become brown or something like this after a while. And that is not only true for polyketone, but that is true for all flame retardant materials we have at Akroplastic. They are always halogen free. They are always free of red phosphorus. They are always antimony triopside free. They are always melanin free. So just to give our customers the security that whenever they buy an FR material from us, it is kind of future proof. So our flame retardant grades are always marked with an FR. Excuse me. So we do not only have applications in the automotive industry, we also have many applications in all different areas. And the reasons why polyketone is used are exactly what we heard in the first presentation. Like for conveyor belts, you have if this is in the food industry, you have food approval, you have a good tribological behavior, you have a high chemical resistance that is needed in this field. Here, there is a drinking water filter, and this is a good example of why it makes sense to come to our booth and have a real look yourself to the part, because sometimes on presentation things look different than in real life. This is real life. So most people expect it to be much bigger. We could not bring all parts. We have now for the Thermomix, from the company Vorwerk, a very high-end kitchen device. We have parts like the butterfly whisk that is used to mix components is made of polyketone. There they use polyketone because they need to make sure after you mix your food, it tastes the same like before and not like some kind of plastic. And it also should be tough, that no pieces break apart and then you have plastic pieces in your food. So what else we have is part on the upper right is the switch mechanism in a light switch. And here POM was replaced for tribological reasons and also to eliminate formaldehyde. So we have transportation chains for the cell industries. This is a very interesting part. It's an impact barrier used in a barrier structure to avoid that a forklift in your production site is running into the pedestrian way. And there were two reasons why polyketone is used. First one is the toughness of the material. And even more important for them was the very, very fast crystallization speed for material with wall thicknesses close to a centimeter, or even in some areas more than 1 centimeter wall thickness. And they were able to keep the cycle time on an acceptable level by using polyketone. And for the Bosch battery slide, it was again the high toughness and impact resistance of polyketone by their use. So I'm not going through the portfolio, but you see we have also unreinforced grades, we have reinforced grades, especially tribological modified grades, and we have flame retardant grades. And we have special grades with approvals for the food industry and for drinking water. That were the examples I brought today. But as I said, we have more on our booth. And sorry for the poor quality. I cut it out from my email signature. But you can find us in hall 6, booth C76. Would appreciate to see you there. Thank you.
Thank you very much, Stefan. So our last section is that the USA distributor and compounder, whose name is Polysource. So please let me welcome Mr. Jeremy. He's tour guide. So it's time to walk.
Move it up.